Example 16, page 70. We're given this function of y, and for part A we have to show the derivative is this. Now since y is a fraction here, we're going to use the quotient rule. As a recap, what the quotient rule states is that you've got some function u over v, so u, that's a v, and the differential of that, so if you've got that y equals this, some function of x over some function of x, then you know that dy by dx is going to be v times the derivative of u minus u times the derivative of v, all divided by v squared. Now in this case, we've got that u is sin x and v is 2 plus cos x. So du by dx is cos x and dv by dx is derivative 2, which is nothing, and derivative of cos is minus sine. Okay, so if we then use our quotient rule, we know that our dy by dx is going to be v multiplied by the derivative of u minus u multiplied by the derivative of v all over v squared. Now already our denominator is looking like it's supposed to, so that bodes well. If we multiply out our numerator, we have 2 cos x plus cos squared x plus sine squared x, and on the numerator that remains as it is. Okay, now if we look at this, that's one of our standard trig identities. We know that cos squared x plus sine squared x equals 1, so we're left with here 2 cos x plus 1 all over 2 plus cos x squared, which is what we wanted here. So we've completed part A. Okay, for part B, hence we're meant to use what we had previously. We're meant to find the values of x at the 2 points on the curve here, which are curve from part A, in this range where the gradient is 0. So if the gradient is 0, we know our derivative is 0, which means from part A we have that 2 cos x plus 1 all over 2 plus cos x squared equals 0. Well, we know that the denominator can't be 0. In order for this to be 0, the numerator has to be 0. So we know that 2 cos x plus 1 equals 0. So cos x equals negative a half. And using a calculator in radians, we have that either x equals 2.09, which more nicely is 2 pi by 3, or x equals 4.19, which is 4 pi by 3. And these are 2 values within our range here. Both of them are less than 2 pi and bigger than 0.